Okay. Well, in the last lesson, we were talking about solving trig equations. And so I just want to go over the method we used before we go into some revision, and then we're going to do some slightly harder ones. So this is what we did in the last lesson. We took trig equations like this one, like this is a sine trig equation, this is a cos trig equation, and this is a tan trig equation. And what all the times, wherever we did, we always started with a reference angle. And when we found the reference angle, we didn't use the negative. So in this case, the cos one is minus 0.86. We ignored that, and we just found a reference angle. In this case, it was 30. And in the case of tan, when I ignored the -1, my reference angle was 45. Give me a thumbs up or a happy face if you understand the idea of finding a reference angle for a trig equation. Give me a thumbs up or a happy face. I really was feeling like you guys were getting this in the last lesson. So I just want to check that my feelings were correct. Okay. Then, after determining the reference angle, we had to establish in which quadrants my answer was going to be in. And so, for example, they haven't done it here, but each of these answers, sine is positive in quadrant 1 and it's positive in quadrant 2. Okay? So that's why there'll be an answer of 45 and also 180 minus 45. So that's quadrant 1 and 2. The answers for cos, where is cos negative? Cos is negative in, let me even draw a little thing here so I can see it. Where is cos negative? It's negative here and here. And so the answer in this one would be 180 minus. Here it would be 180 plus. In the answers here, you see it's 180 minus the reference angle, and it's 180 plus. And then the two answers they were getting were that and that. And then in this one, because tan actually, you can do 2 quadrants, but because the period of the tan graph is 180, we actually need to do 1. And so what they've done here is they've said, where is tan negative? Well, tan is negative in quadrant 2 and quadrant 4. But because of the period of the tan graph, you only need to do 1 of these. And in this quadrant, it's just 180 minus the reference angle. And so my final answer will just be 180 minus 45, which is this. Now, in this case, they said write down in the interval 0 to 360. Well, all of these answers, oh, okay. Yeah, you could do more of them. But I'm not going to go into too much detail. And then I also spoke in the last lesson about something called a general solution. And what a general solution does is it takes the original answers and adds a k times 360 for sine. It adds a k times 360 for cos, and it adds a k times 180 for tan, where k, and then it also says where k is an integer in all of these. Give me a score out of 10 about how well you understand this method, where 10 is you understand it perfectly, 0 is you have very little understanding. I want to get a feel for how many examples I need there. Answer. So 10 is perfect. And like 0 is like very little. And then, okay. So let's just do a couple here. So this question says, list all x values in the range 0 to 360. So it says basically means find the value of the answers for 0 to 360. And I want you to do it for sine, so for A. I also want you to do it for B. And I want you to do it for C. So I want you to solve these 3 trig equations by yourself using the method I showed you last time. But if you get stuck, I would love you to raise your hand and then ask me a question. We can talk through where you're getting stuck. The hints I will give you is that each of these questions will be a 3-step process. And your first step will always be to find the reference angle. Okay, over to you guys. I'm going to give you about 4 to 5 minutes to do this. I really want, when you're done with A, just say A, done, B, done in the chat so I know. But I really want to give you a chance to do this yourself. So I'm going to give you some quiet time, and you just let me know if you need some help as you do these 3 questions. So over to you guys. I believe in you. So Tinswallow, I see you've just joined us. We are just practicing 3 trig equations to get started today. And the 3 trig equations we're doing are the ones in green. And you have to find me the answers between 0 and 360. And yeah, see what you can do. What is my reference angle for sine going to be? Let's see if I can find my calculator. Do together as we go. Let me go and find it. What did I put mine? Calculator. I was doing a cleanup the other day and I think I cleaned up too much. Okay, Nicole's asked, sir, if the number is positive, should we find the quadrant with the number is positive in? Yes. So to give you an example, Nicole, let me get rid of this one. For question 1, we know that sine is positive in these 2 quadrants. And so my answers are going to be 180 minus the reference angle, or they're going to be the reference angle. So Nicole, can you help me? What did you find for shift sine 0.2? What was your reference angle? What was your reference angle that you got? Okay, 11.53. Now, our answers, like we were saying, are going to be in quadrant 1 and they're going to be in quadrant 2 because that's where sine is positive. And so x will be equal to 11.53. Let me make this a bit thinner. Or x is going to be 180 minus 11.53, which is going to be, you can help me out, but it's going to be about 168.47, I think. Just confirm if that you get the same as that. So the 2 answers are 11.53 and 168.47. Yes, they are. Perfect, perfect. Smiley face for all of us. So now I want you to move on to number 2, or to B and C. Can you solve those trig equations in the range 0 to 360? And maybe somebody can remember there's something a little bit sneaky about B. There's a bit of a trap that we could fall into if we're not careful. Get rid of these other examples here too, so they don't distract us. So the thing that some of you might get caught out with is when you find the reference angle, you need to use a positive value, not a negative value. So what do I get for my reference angle for this one? Yes, Nicole, there's a negative, exactly. So when we have, I see Viwe also noticed that. So we know that the answers for the B are going to be in the 2nd and 3rd quadrants, and they're going to have the form 180 minus the reference angle, or 180 plus the reference angle. But I still haven't got a reference angle, so can someone help me out? Who has a reference angle for me? Shift cos 0.3, what do you get? I know my 2 answers are going to be in quadrant 2 and quadrant 3, but I need a reference angle. So Nicole got 72.54. That sounds pretty good to me. Callan agrees. So we are on the road to success. So now the question is, what are my final 2 answers here? X is going to be equal to something. Well, let me use black because it stands out nicer. X is equal to something, or X is equal to something else. I think it should be 180 minus 72.5, or let me get rid of this, 72.54, or x should be equal to 180 plus 72.54. So what are my final answers going to be then? This one is a bit easier. It's going to be 252.54. But what about the other one? So it's going to be 107.46. Absolutely. And yeah, those are going to be the answers in the range 0 to 360. So we have smashed those two, and that was definitely the harder one because we had to ignore the negative. And just to remind you why that happens is that you ignore the negative in step one because you take into account the negative in step two. When you decide what quadrants you're in, you go for the negative quadrants. So you can't like kind of include the negative twice. You just handle it in the second step, and that's why you ignore it in the first step. Okay, last one. Let's go. Tan x equals 7. What solutions are there to that trig equation in the range 0 to 360? So what is my reference angle for this one? So Nicole, can we get a confirmation? Nicole has given us 81.869. I'm just going to round it off to 81 point, I'm going to round it off to 81.9 for now. That looks pretty good to me. Now, what quadrants? Yeah, Callan agrees. Okay, fantastic. And Vue is, okay, that's from the previous question. All right, now, where is tan positive? It's in quadrant 1, reference angle, and it's also positive in quadrant 3, which would be 180 plus the reference angle. So the answers are going to be 1 in quadrant 1 and quadrant 3. Now, what are those final answers going to be? Well, I suppose quadrant 1 is easy. It has to be 81.9. So we say x is 81.9. But what about the second answer? Where is that going to be? Well, what is that going to be, rather? I think it's just going to be 180 plus the 81.9 because it's in quadrant 3. So we go 180 plus 81.9 and we get 261.9. And those are my two answers in the range 0 to 360. Now, these are specific solutions in the range 0 to 360. If I wanted to make them general solutions, all I would do is I would add the k times, in the case of the first two, 360, and in this last one, I'd add k times 180. Give me a score out of 10 of your understanding of these types of questions. So 10 if you feel very strong, 0 if you feel you have no understanding, 5 if you sort of have understanding. Give me a score out of 10, and then I know how the examples do I do after this. Okay, so we're trending upwards. So you know what? You guys are growing up fast, so it's time to take on a different type of trig equation. I would love to hear a human voice. Who feels like they can share with me what is different about this, solving this trig equation? Who is going to put their hand up and seize the day? Carpe diem. Who feels like they can recognize what is different? And for bonus points, what does the thing that's different actually do in this trig equation? That's like serious bonus points, brownie points. Second prize is a comment in the chat, but really we want to hear some human voices. That's what we want to feel. So who can tell me what is different compared to the last one? What do you notice? There's only one small little thing. I feel like Callan wants to tell us. Callan, what do you think is different about this yellow one that I am pointing to?
So theta has a multiple of 2, and we have to divide it. Once we find our proper amount, we have to divide it in our sum.
Perfect. You nailed it. Thank you so much, Callan. So I'll rephrase that because it's important. There's a 2 in there, and what that 2 actually does is it changes the period of the graph. Now, I'll only show you this at the end, but if you think about a normal cos graph, a normal cos graph has a period of 360. So you'd fit a whole cos graph in 360. You'd start at, this one has changed, but the good news is the 3-step process is still the same. So I want you guys to find me a reference angle. That's all I want you to find me. Find me a reference angle for this trig equation. And I want to see what is in the chat there. Reference angle, that's all I want. Follow the rules of what's going on here. Who can give me a reference angle? Following the ideas that we followed so far, right? Now, the important bit is you need to ignore the negative. And Nicole, I think you are on the right track, 72.3 degrees or 71.2. Oh, okay, which one is it? Who can give us a confirmation? What is our, it's clearly in the order of 70 degrees, but you need to go shift cos 0.6427. And what are you getting? Let's round off to 1 decimal place. Who else can give me a confirmation here? So do it on your calculator, pop it in the chat so we can get some confirmation. We need to get confirmation from another student in the class before we can move on. Ooh, things are going all over, just to check, but we need to make sure. So shift cos 0.6427. Who else gets, let's have the whole class do this because we shouldn't be getting such variation. And I can also do it on a calculator in the background. So inverse cos 0.6247, I think it was, huh? Let's have a look. What are we getting? Oh, no, don't divide. Don't divide. All you want to do is I'm getting, so you shouldn't, Sam, I'm getting C. So ignore the stuff inside and we've got 6427. So 64, so I'm actually just using Google to do this now. And I'm getting 50.006, which I see Callan is getting the same as me. Okay, so 50.006, we can just round that to 50.01. So we should get, let me go back here, 50.01. We ignore this 2 for now. We will deal with it later. But everyone, are we in agreement that we get, give me a thumbs up if we're happy that the reference angle is 50.01. Because this is important now. It's getting, the questions are getting harder, and so we need to make sure we don't get off the train here. Okay, so Sam, no, we're going to divide by 2, but later. Not yet. Okay, now, second step is in what quadrants is, now this is cos, which quadrants is cos negative in? I want to know, where is cos negative? Because isn't cos, it's negative 0.6427. We have to take that into account. So where is it negative? It's in quadrant 2 and 3. Now, in quadrant 2, it's 100. Let me even draw this. Let me zoom in a little bit so it gets a bit bigger. So let me make this a bit bigger as well. So we know that the answers must have the format 180 minus the reference angle, so 180 minus, and they must also be 180 plus. So they're in quadrant 2 and quadrant 3. But you may say, hold on, Mr. S, you need to deal with this 2. You haven't dealt with this 2 yet. And you're right, I haven't. But you know what's about to happen? I'm going to deal with it in a moment. So what we're first going to do is what we're going to do now is, instead of writing, normally we would write x equals. We're not going to do that this time. What we're going to do is we are going to write 2 theta equals over here, and we're going to write 2 theta equals over here. And you may say, why are you using 2 theta? Well, look inside the cos function. What is the thing inside that cos function? It's 2 theta, so we write that down. Now here, I'm going to write 180 minus the reference angle, which is 180 minus 50.01. And over here, I'm going to write 180 plus the reference angle, which is that. Give me a thumbs up if you follow my thinking in what I've done so far here. The way that I've taken this new 2 theta and I've made it kind of behave like an x before. Okay, now, for all those people who wanted to divide their 2's, now is your time to divide some 2's. So you'll notice that 2 theta is going to be equal to 129.99, and 2 theta on this side is going to be equal to 230.01. I want you guys to find me what are my final 2 answers for theta. And you're right, you do now have to deal with this 2. But the good news is the way to undo a multiply by 2 is to divide by 2. So give me my answers for this trig equation. What do I get if I divide this one by 2 and this one by 2? Let's see those answers in the chat. Come on, everyone. What do we think it is? Well, I'm pretty confident the last one is going to be 115. So basically 115, and then it'll just be point. Yeah. So in fact, I'm going to round it off. It's essentially going to be that. And then this one over here is going to be 64.995. Or, it's essentially, if you completely round off, it would be 65, or theta is 115. And that is it. Okay. Everyone, you have just handled a much harder trig equation, and all we had to do was keep things exactly the same until the last step, and then we replaced what was normally an X with the thing that was inside. And that's it. So I think you did very, very well. Sam, you're absolutely correct. You're on the right. Yeah, you're fine. All right, time for a quick little break. So I want everyone turn your cameras on so we can see each other, and let's just do a quick little exercise break. And then we're going to do a second half where we carry on doing some slightly harder ones, but we'll do them very slowly and you'll build up your understanding as we go. Okay, so what do? We're going to start by just some breathing. So in, out. One last big breath. Oh, the oxygen feels delightful. Okay, let's loosen up. We want to shake up our arms. Shake out the other arm. You want to get nice and relaxed. You do really good maths when you're nice and relaxed. Shake out your legs. Shake out your other leg. Let's roll the shoulders back. You can look off into the distance so that your eyes get a break because you've probably been staring at a screen. Change the direction of your shoulder roll. Okay. And then put your arms out like this. We're just going to do a gentle twist from the hips. And as you relax, your body will naturally turn more. Oh, I can hear clicking. Can you hear my clicks? And that's not my mouse clicking. Oh. Okay, then you know what's coming? Some heart rate stuff. We are going to do jumping jacks, and we are going to do how many of them? 15, because we can. In 3, 2, 1, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I feel like an aerobics instructor, but I do feel like my brain is happy with me. So I will continue to do it. And then just a little break. We already solved the red one today. That can solve this math question 24 using more numbers. The recording will be available almost within a day, I think. So just watch that first half. In the second half of today, we're going to the harder trig equations. So if you feel a bit unsure, don't stress. You can catch up by watching the recording when it comes out. Okay, but let's try and get this. Who can make 24 using these 4 numbers? Manila, I feel like you've got it. I can feed it through the internet. You're just keeping it to yourself. share your knowledge with us. Sam, any ideas? What do you think? I actually don't have this yet myself. What do I do? I feel like, I want to add 2 and 1 together and get 3, but then I can't. I have to deal with the 7. 2, 7. I haven't actually got this one. So I'm open to suggestions if anybody can. Naledi, let's have a look. 8 times 2 is 6. Oh, you've got it. Naledi, you smashed it straight away. So 8 times 2 is 16. And then 16 plus 7 plus 1 is 24. I do declare, Naledi, you are the Maths 24 wizard for today. Well done. Okay, so let's go and have a look at a similar question. And let's not even do that one. Should we do that one? Solve. No, actually, you know what, guys? I'm remembering something from the last question. We didn't find the general solution yet. The question actually asked us for the general solution, so I just want to show you what the full general solution would look like. We've got the answers at the moment, but the full general solution would be theta is 65 plus k times 360, or theta is 115 plus k times 360. Oh, it wouldn't even be that. Okay, hold on. Let me not say it wouldn't be that. And the reason it wouldn't be that is that the period of the graph has changed. So let me take that on. I'll explain it to you in a later lesson. But the period of the graph actually halved. So it would actually be k times 180. Okay, but let's rather than go for this one, and then I'll do the general solutions later on. So we are going to solve this one. And the thing that's different this time is the period is not changing, but there clearly is something funky going on. But the good news is step 1 is the same, step 2 is the same. Step 3 is where maybe something interesting happens, but I would like everyone to tell me what their reference angle is, and then I also want everyone to tell me what quadrants they think the solution will be in. So over to you guys. You tell me what you get. I'm going to move this one a little bit. So what is your reference angle for this trig equation? And what is your so what is your reference angle and what quadrants are you in? Okay, so Sam got 45.008. Sam, I'm going to round it off to 45, but I want to wait for confirmation from our other classmates. So who can give a thumbs up for Sam's answer? Naledi, Viwe, Manila, Nicole, who got 45? Anyone else get a 45? Okay, 45.0. Okay, I'm going to round it off to 45 just to make life easier. So Naledi's on the bus. Okay, fantastic. Now, which quadrants is cos positive in? I think it must be quadrant 1, but it must also be quadrant 4. So we know the answer will have this format. And what I'm going to do is I'm even going to write it out in the proper formal way. Now, here is what's different, and maybe you can see this coming. Down here is that theta minus 25 equals something, or theta minus 25 equals something else. I want you to tell me what are the some things that I'm hiding from you. So theta minus 25. In fact, it's not even theta, it's an alpha. Sorry, my Greek letters are not being, because that looks like an alpha up there. But you know what I'm doing. So what do you think I'm going to put in the box here? What do you think goes in box number 1? Let me actually get rid of this one. Let's just do box number 1 first. What goes in box number 1? It's 45. Yes, it's 45. Now, if I want to make this a general solution, and this question did ask for a general solution, what I'm going to do is I'm going to add a k times 360 now. And the reason it's k times 360 is it's the cos function. Okay, now that is what's called a general solution because it generates all the solutions. Okay, now what about box number 2? We know we've got alpha minus 25 equals something. And to be honest, I'm going to put the k times 360 from the beginning here. What goes in box number 2? Oh, and my drawings made a mistake. That shouldn't be 180 minus. This should be 360 minus the reference angle. I'm giving it away, but watch out for silly mistakes like that, because I know cos is positive in quadrant 1 and 4. So what goes in box, I'll call it box number 4. It has to be 315, because it's 360 minus the reference angle. And then the other thing is, for a full general solution, I need to have this thing about what is k even doing. Okay, now I want you, on the next line, I want to get alpha all by itself. So alpha is going to be equal to something plus k times 360. Tell me what goes in this box over here. Or alpha is equal to something over here. So I think that the minus 25 is kind of stuck and it needs to move. And I also think the minus 25 in this one needs to move. So the question is, what do I end up with? And you're quite right. Here, we're going to end up with 70 because this moves across. So alpha is 70 plus k times 360. Or what is the second alpha going to be? What is the second? Well, this is going to be 315. When this comes across, it becomes plus, so that becomes 340. And you know what, ladies and gentlemen, you have now solved an even harder trig equation. The two solutions are 70 and all 360-degree multiples of that. And then it's 340, and those are my solutions. So give me a score out of 10 for how you're feeling about this type of question. So 0 is no understanding, 10 is perfect. Give me a score about how you're feeling about this. Okay. And remember, I can't see your faces always, so I need proper feedback from you in this space. Okay, now let us do one with tan. And you know what? You've done so well tonight. We're going to take on one where we don't just change the period of the graph. We also have basically a translation. So we are going to solve this to end today. What do you think is step 1 to solve this one over here? What do you think is the first step I'm going to do to solve it? I want people to tell me. Reference angle. It's almost so predictable, isn't it? Reference angle. And what is my reference angle for tan going to be? I'm going to start relying on you almost entirely now. So the reference angle is going to be the inverse tan of 5, but you're going to need to get some help from your calculator. So what is inverse tan of 5 equal to? What is the actual reference angle going to be? 78.69, or I'm going to round it off to 78.7. Can we get a confirmation? Can we get a classmate who's willing to confirm that they agree with Naledi? Callan agrees. Fantastic. Okay, now, what do you think my second step is going to be? What do you think my second step is going to be? Quadrats, yes. Where is tan positive? Exactly. And tan is positive in quadrant 1 and quadrant 3. Now, I'm even going to put the formats here. Now, what is interesting is that with the tan, and this is where there's two ways you can do this. Now, with the tan graph, because the period by default is only 180, we don't actually have to do both, but it's not wrong to do both. And so for now, I'm going to do both just because it's easier for you to see. But in reality, if you do enough of these, you'll know that with tan, you only have to do one of these two and you get all the answers. But let's pretend for now we didn't know that. So what is going to be my third step? What am I going to write? I'm going to write something in a box down here, and I'm going to write something in a box down here, and I'm going to go equals. What is in box number one? In fact, so in box number one this time is going to be 2 alpha minus 10. And I'm going to go equals something. And then on this side, I could also go 2 alpha minus 10. The question is, now I can have some things here. And there's also going to be a little bit of extra stuff at the end here too. There's going to be a plus k. So what is inside this box? Well, it's going to be 78.7. Okay. Now, what would be in this box over here? Let's say in the blue one here for quadrant 3. What would be in that box? So remember, in quadrant 3, this thing is going to be 180 plus the reference angle, because it's this one over here. So we go 180 plus 78.7, which would be 258.7. The other thing is that the tan function has a period of 180. So that is going to be plus k times 180, and that is going to be plus k times 180. Now, at this point, I'm going to stop doing the third side because it's going to get a little bit too busy. And like I said, with tan, we only need to do the one branch and we have limited time left. So we're just going to focus on the solution in quadrant 1. So we need to now solve for alpha. What do you think my first step is going to be in solving the thing in the big black box now? What is going to be my first step in solving what's in the big black box? Am I going to deal with the 10 or with the 2? And it does make a difference. What do you normally do when you solve an equation? Which one would you deal with first? I think, no, it's not the 2. Okay. You have to isolate the alpha, and so you have to deal with the 10. So what happens is you go 2 alpha equals, and you bring it across, and you're going to get 88.7 plus k times 180, where k is an element of integers. Okay, so now you have got rid of the 10. It's almost like an equation, you know, when you move it across. Now you have to deal with the 2. What am I going to do with the 2 to get rid of it? I'm going to divide both sides by 2. But watch out, ladies and gentlemen, because that blue is rather thick. I actually have to divide both of these things by 2. So what am I going to get for alpha in the end for my answer? What is alpha going to be? Well, I know I have to take 88.7 and I need to divide it by 2. So what do I get? I should get 44.35. But I also have to divide k times 180 by 2. And you know what, everyone? If you divide 180 by 2, you're just going to get k times 90. So the general solution to this quite difficult trig equation is alpha is 44.35 plus k times 90, where k is an element of the integers. So what happened was this 2 in front of the alpha, it halved the normal period. The normal period of tan is 180, but because of that 2, the period of this particular one would be 90. Now that's about as hard as we're going to handle here right now. If you need to rewatch that last, but don't stress, that's a pretty tricky one. But I think over the last 2 lessons, we've really got to a stage where we've really got the basics of, well, not the basics, we've got actually some quite hard trig equations under our belt.